Okay, hi everyone, my name is Ivana Shen, and this is my second year in the bioscience program, and thank you everyone so much for coming to our talk. Okay, so I bet all of you guys recognize this guy. And after 4 years of being the President of the United States, he becomes this guy. It certainly would seem to support the old wives' tale that stress causes hair to turn gray. But is it really just an old wives' tale? Let's dive a little bit deeper into the process of hair becoming gray. Before his gray started, his hair should look like this, full of pigment. But when he started to get gray hair, this is what's happening. In early stages of gray, the cells producing the pigment are still present but are just inactive. But later on, they seem to decrease in number or disappear altogether. When people started to get gray hair in their early 20s or even high school age, it is considered to be premature gray hair. So, is it just bad luck that people get premature gray hair? Scientists have actually shown that there are certain factors that could increase the risk of getting premature gray hair, like smoking, genetics, or poor diets that leads to vitamin deficiency. However, scientists have never shown that stress could increase the risk of getting premature gray hair. So what is stress? Stress is our body's reaction to harmful situations, whether they're real or perceived. When you feel threatened, your body will respond by literally releasing a flood of stress hormones that could rouse our body for emergency actions. Your heart will pound faster, your breath will quicken, and your mind will become sharper. However, the stress response was only meant to be used in situations like this. However, this type of situation should really only happen once in a while. But these days, everyone tends to be stressed all the time. In young people, one additional source of long-term stress is academic stress. Since the stress response system should only be used once in a while and for a very short period of time, this long-term continual activation of our stress response system and the overexposure of our body to stress hormones can lead to serious health effects. Like, it could decrease your immune system, or it could increase the risk of getting cardiovascular disease. It could also lead to digestive system problems. So what is really wrong in those pictures? The problem is not the gray hair. You're not going to die from gray hair. But what if gray hair is just the tip of an iceberg and we just don't see other physical problems developing due to stress? If academic stress is really causing hair to turn gray, it could be the first visible sign of all the other known or unknown problems developing due to stress. So that is why it is important to determine the relationship between premature gray hair and academic stress level. A few years ago, a BioScience student did a pilot study hinted at the possibility that there's a positive correlation between premature gray hair and academic stress level. He surveyed people about their high school academic stress level and whether they had premature gray hair or not. He measured people's stress level using a tool called ESSA, the Educational Stress Scale for Adolescents. This scale measures people's stress level by means of a survey composed of 16 questions regarding their high school academic life. So, for people who reported they did not develop premature gray hair, their average score was 52.1. And for people who reported that they did develop premature gray hair, the score was 58. So, does this difference mean anything? To determine whether the difference between those two scores are due to the effect of stress, I need to calculate a p-value. A p-value is the probability that the results are due to random chance. And using the t-test, I was able to get a p-value of 0.009, which means the probability that my results are just due to chance is 0.9%, indicating that the difference between those two data can actually be under the influence of the increase of stress. This is really exciting because there's no scientific evidence has ever shown that those two factors have any correlations. So last year, using the same method but with a much larger population and a different statistical analysis tool, chi-square goodness of fit test, I did my preliminary study and got similar results. Totally intrigued, I decided to look into this further. So this year, I refined all my questions for my official survey. By incorporating other questions regarding age, gender, and ethnic groups, I created my official survey. Then, I utilized the Mechanical Turk, which is a crowdsourcing platform to distribute and find participants for my survey. I simply put a link in my survey on Mechanical Turk and award every person who successfully complete my survey 25 cents. And I was able to get 600 results. And here are the data. This is the raw data, and along the top are the stress level people have, ranging from low stress level on the left to high stress level on the right. And along the side are whether the participants developed premature gray hair or not. And to statistically analyze my data, I mainly focus on the positive responses. I compared the number of positive responses with an expected value, which is calculated with the assumption that regardless of your stress level, everyone has the same chance of getting premature gray hair. To determine whether those two sets of data have statistically significant difference, I calculated the p-value using chi-square goodness of fit test, and I was able to get a p-value of 0.992, meaning that the probability of my results are just due to chance is 99.2%, which is almost 100%, and it was really shocking to me regarding considering the p-values I had before. So, looking back, I found out that it was my insufficient knowledge of statistics that causes those two results. In the pilot study, the t-test that students used is far less sensitive than the chi-square goodness of fit test I used. And in my preliminary study, even though I used the correct statistical tool, I have a false understanding of how it should be used and calculated. So, in both those two research, I made some mistake in the analysis of the raw data, creating those two unreplicable results. After I have a full understanding of the chi-square goodness of fit test, I recalculate the results from my preliminary study, and the p-value turns out to be 0.62, meaning that there's a still very large possibility that my data is just due to random chance. So, for my research, I can conclude that there's insufficient evidence to support my hypothesis, and premature gray hair does not appear to have positive correlation with academic stress level in high school. So, this is not exactly the results I'm hoping to get, but I did learn a lot along the way, including something that I never expected to learn. So in real scientific world, there's the similar problem is also happening, and at a scale that I could never imagine. It is called the replication crisis, meaning that scientists could not reproduce others or even their own research. When I first looked into this, I thought it was totally due to academic fraud or falsifying data. However, when I look into this more, I found that there's a variety of reasons that can cause this crisis, like insufficient knowledge of statistics like me, or failure to adhere to laboratory procedures perfectly. with this knowledge in mind, I will both be more open-minded to other people's research, and I'll be more skeptical about the results they get later on in my life. Thank you.